For basic static analysis, we will be first using Jyoti's malware scan in order to get a general idea of what the malware and the nature of malware is by letting it be scanned by a group of antivirus scanners. The website has finished scanning the malware, and almost all of the antivirus scanner has determined that this malware is perhaps a Trojan or Win32 malware executable file. So after we have known the nature of the malware, we can use the basic static analysis tools to find out more about the malware. Okay, so the first would be to check if the malware is packed. PEID is a good tool that can be used to help check whether the malware is packed or not. Okay, so the compiling environment is not shown. Instead, upolyx version 0.5, a known packer, is shown. Hence, this malware is packed. So in order to unpack this malware, we can use tools such as Fast Universal Unpacker. After dragging the malware into Fast Universal Unpacker, I've decided to try all of the Unpacker plugins. However, it seems like they are unable to unpack this malware, as the results are quite disappointing. None of the plugins were able to unpack the malware. Hence, I decided to try another unpacker software called Packer Breaker. After dragging the malware executable into Packer Breaker, the Packer Breaker has successfully unpacked the malware and has generated a unpacked version in the desktop. To see if the unpacked version is a correct unpacked version, after dragging the unpacked version inside, a Windows icon graphic format is shown in the compiling environment section. However, Windows icon graphic format is not a known compiling environment, so perhaps this malware is not completely unpacked. However, I have decided to continue on, as using dependency walker to compare the number of information that it shows compared to the malware. It shows a lot more functions, as it displays 8 DLLs as compared to the malware's 3 DLLs. Hence, I've decided to continue on with this unpacked malware. So the next step would be to find the hash of the malware and the unpacked version. So after dragging it in, the hash is generated by winmd5. Hence, once we know the hash, is a unique way to identify the malware. After which, in order to know more about the unpacked malware, we'll be using PEview in order to run and see the header of the malware, unpacked malware. It shows the date of when it was compiled and made and the time. Hence, this gives us more insight onto when the malware was created. Next, we'll be using dependency walker, as shown just now, to see all of the DLLs, as it imported all these DLLs with all the functions inside. This could give us some insight as to what methods they are trying to use. In addvapi32.dll, there are a few suspicious functions such as adjust token privileges, which means that it could be trying to escalate its privileges. Registry create key close key could mean that it's trying to do some host-based indicator method, which could mean that it's trying to manipulate the registry. And perhaps Open process token means that it could be trying to open a certain process token which is gets from get token information function. In kernel 32.dll, there are suspicious functions such as load library, which means that the malware has its own library in order to get its own functions instead of using the Windows library, DLL libraries. And remove directory could mean that it's trying to delete an entire directory. Create file could mean that it's manipulating the files. And flush instruction cache means it's trying to manipulate the information and instructions so to run its own program. Oreo 32.dll could, with its sysallocation function, could mean that it allocates a new string and copies the past string into it. This malware could be trying to do some string manipulation. In RPC RT4.dll, there is such functions such as changing UUID, binary UUID into a string UUID, or creating UUID so that the original UUID will not be found. In user32.dll, there are functions such as wvsprintfa, wsprintfa, and message box. Could mean that it's trying to write formatted data to a specified buffer, or display a model dialog box that contains a system icon, a set of buttons, and a brief application-specific message, hence manipulating the message box. WinINet.dll has a lot of suspicious functions that is called. Perhaps it's trying to connect to internet, a certain URL, or maybe it's trying to hide its URL using internet crack URL by breaking up its URL. Internet read file, perhaps getting instructions from the links that you might go to. ws2_32.dll has 3 functions, which could mean that these functions allow the malware to specify version of Windows socket required and retrieve details of the Windows socket. INET address could convert a string containing IPv4, perhaps this is the URL or IP address. And get host by name method retrieves host information corresponding to a host name from a host database, perhaps from its backend server. And urlmon.dll states that it is trying to perhaps obtain some sort of string manipulation. So moving on, we'll be next using bintext to further look into the strings to see if there's any more suspicious strings. And in here there are more suspicious strings such as service.exe, perhaps it's trying to run its own executable file. Create process, perhaps it's trying to hide itself by perhaps in a legitimate process, connecting to websites so that you can receive its instructions. And perhaps an IP address, perhaps this is the IP address of the website it's trying to connect to. Hence, from this tool, I'm able to see all of the various suspicious strings that might be connected to this malware.